Okay, this is section 2.2.2. What does the unit circle tell me? So you don't have to wait so long to get your questions answered on homework questions. If you want to send me an email, I could make a video and post it going over some of the questions that you have so that you can get your answers a little sooner. What does the unit circle tell me? We spent all of last class building our unit circle using our special 30, 60, 90, and 45, 45, 90 triangles, and learning how those side links related to the ordered pairs for the angles around the circle. So today we're going to go a little further and say what else can we figure out from it. So if you want to go ahead and get your unit circle out that we made the other day, we're going to need it. I'm going to fill out this little table. Oh, I had one question for you. 2-56, the last sentence is, what was the length of the hypotenuse for each of those special right triangles that we used the other day? And the length of our hypotenuse was always 1. So we have theta in radians. We have theta in degrees. We have the cosine of theta and the sine of theta. And theta is just a nice Greek letter, like a variable, for our angle. So instead of using x, they use theta sometimes. So I'm just gonna tell you what this one is. And then I'm gonna go through figuring this one out with you. We have pi over 6, that's 30 degrees. I'm going to draw our 30, 60, 90 here. Hypotenuse was 1, this was a half, and this was square root of 3 over 2. So if we wanted to find the cosine of 30 degrees, it is A. Using our right triangle, we got our H. For 30 degrees, this is A and this is O. So it's A over H because cosine is ca. And that is just the square root of 3 over 2. And the sine of 30 degrees is O over H, half over 1, which is just a half. Let's do another. Let's talk about pi over 4, which is 45. And we'll draw our little 45, 45, 90. Both of mine look the same. Hypotenuse is 1, and these sides are both square root of 2 over 2's. So I'll scoot over a little bit. The cosine of 45 is A over H, which is just square root of 2 over 2. And the sine of 45 is also O over H, which is square root of 2 over 2 over 1. All we're doing is labeling hypotenuse. We'll use this 45. Put your O and your A. You could have used either 45 if you wanted. And we just did SOHCAHTOA here. Ka. So, ka. So, B part. What patterns do you notice between the values in your table and the coordinates of the corresponding points? So the values we found in our table and the coordinates for these points on our unit circle from the other day. If you're looking at your unit circle, the coordinates that we wrote down for 30 were square root of 3 over 2 and a half. And the coordinates we wrote down for 45 were both square root of 2 over 2. Is it just a coincidence that the x value is that right there and this y value is this right here? Did the same work over here? X value, y value. So it turns out it's not a coincidence. Every angle on the unit circle, its xy coordinates are in the form of cosine of that angle and the sine of that angle. So that's hugely important. I'm going to write that again over here. So xy, x is the cosine of theta and y is the sine of theta. right, C part wants us to talk about the range of cosine. Range is the y values. So look at all the y values for the angles on the unit circle. They go from 0, a half, square root of 2 over 2, square root of 3 over 2, to 1. And then we have repetitions of those where some of those are negative, all the way to -1. So what is the smallest y value that you get? The smallest y value is actually -1, and the largest y value is +1. So y goes between -1 and 1. If you're not sure if 1 is greater than square root of 3 over 2, you could just do that on your calculator if you'd like. Or you might remember when we go around our unit circle and we count by square root of 2's. Over 2's? No. Yeah. By square root of 2 over 2's to get the 90, 180, 270, 360. We get to square root of 4 over 2. Square root of 4 is 2. And 2 over 2 is 1. So 1 is actually the biggest y value. And -1 is the smallest y value. Alright, C part. Connor draws a circle with a radius of 3. Oh, let me back up. The other way that the book said to think about it was all the values on the unit circle come from these special right triangles. All the values except for these quadrant angle values. Those come from the fact that we take a 1 unit radius and we swing it around and we make a circle. So that's how we get this 1, 0, 0, 1, -1, 0, 0, -1. All the other ordered pairs around this unit circle come from this right triangle whose hypotenuse is 1. So the 1 is the biggest value. So these y and x values have to be smaller than 1. Okay. C 2-57. Connor draws a circle with a radius of 3 and uses a special right triangle to label the coordinates. That's my dog. So Connor drew this right here. Said he had a radius of 3. So he was using 5 pi over 6. So that is actually, if this is pi, do you agree that this would be 6 pi over 6? So there is a pi over 6 difference right here, which would give us a reference angle of pi over 6, or 30 degrees. So it's a 30, 60, 90. And the side opposite the 30 is always half of the hypotenuse. So this is 3/2, or 1.5. So Connor says that the sine of 5 pi over 6 is 1.5. And we have to say if we agree with him or not. So when I look at this unit circle, or this circle, the sine is the O over the H. Maybe we'd rather see that this way. Maybe we want to multiply both of those by 10. And then 15/30 is a half. So Connor was off a little bit. It should have been a half and not 1.5. All right. Last but not least is 2-58. You have observed how sine and cosine relate to the unit circle. Remember the x and the y give us the sine, theta, and the cosine. Whoops, I did that opposite. X and y give us the cosine theta and the sine theta. But what about tangent? So 2-58 says, what about tangent? So it wants us to look at this little diagram at the right. My dog is scratching and ready to go outside. We're almost done. And we have a little right triangle here with theta. This is some y value and that's some x value. Refer to the diagram at the right and determine what the tangent of theta would be. Well, tangent for SOHCAHTOA is O over A. So for that theta, this is O and this is A, because this is my hypotenuse. So tangent O over A is Y over X. Isn't that funny? Because we just said Y was the sine values and X was the cosine values. So we learned that the tangent is sine of theta over the cosine of theta. This is called a quotient identity, and it's a really important identity. That's going to show up a lot in the next few weeks. I figure it out a different way. So if we think about the 30-degree angle, it was a sine of a half, and a cosine is square root of 3 over 2. I think through this way, if this is cosine and this is sine, well, cosine is ca, and sine is so. And tangent is, watch this, TOA. You see the O and the A here that I'm circling? There's tangent sitting right there. So you could go back to this ordered pair here for the 30 degrees, and you can get sine is so, cosine is ca, so right here is TOA. So the tangent of 30 degrees is O over A, and we'd rationalize that. Okay. I don't know how that went for you. Please email me if you have any questions, and email me if you have homework questions. All right. Bye-bye.